بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Section 3.1 The derivative. The aim of this section to relate the concept of derivative at a number a to the slope of the tangent line to the graph of y is equal f of x at the point of tangency a f of a, and to evaluate derivative using the definition, which is definition 3.11. So we have seen that from section 2.7, the tangent line is given by m tangent is equal limit f of a plus h minus f of a over h when h approach to 0. And we call this one is the slope of the tangent line, or the slope of the curve at the point a f of a. In this section, we see that the definition of derivative, which is definition 3.11, is given by the derivative of a function y is equal f of x at x is given by f prime x. So f prime x, this one represents the derivative. It is equal limit f of x plus h minus f of x over h when h approach to 0 whenever the limit exists. So it is the same definition, but the difference here, we take this one at the point a f of a, and for this one take it in the general way, which is at the point x f of x. So the m tangent and the derivative, they are the same, just the m tangent we take it at a point, specific point, which is a f of a, whereas the derivative we take it at the general point, which is x f of x. So here we have example 1. Find the derivative of f x is equal x squared plus 2. Let us see how to find the derivative of this function using definition 3.1. Here we have f of x is equal x squared plus 2. We ask to find the derivative. So we know that f prime x, or the derivative, is given by limit of f x plus h minus f of x divided by h. We evaluate the limit when h approach to 0. So let us apply this in our function. So this will give us limit fx plus h. We go to the function f, replace any x by x plus h. So this will give us x plus h all square plus 2 minus f of x, which is the same function. So this will be minus x squared plus 2 all divided by h. We evaluate the limit when h approach to 0. So now we need to simplify our function. X plus h all square, this will give us x squared plus 2xh plus h squared, then plus these two. Here we have minus x squared plus 2, so it will be minus x squared minus 2 all divided by h. So now we need to simplify. So here we have x squared, we have negative x squared, these two will cancel. Also we have 2 and we have minus 2, so these two will cancel. So we left with, this will give us, it is equal to limit of 2xh plus h squared divided by h, and here we have when h approach to 0. Now we have 2xh plus h squared over h when h approach to 0. We can take h as a common factor, so this will give us limit of h 2x plus h divided by h when h approach to 0. So again here we can cancel this h from the numerator with h from the denominator, and the rest will be, this will give us limit of 2x plus h when h approach to 0. So since this one is a polynomial, just we need to replace h by 0, so this will give us 2x plus 0, which is equal to x. So we conclude here f prime x is equal to x. So the derivative of x squared plus 2, it is given by 2x. Using the definition of the derivative, we have seen that the derivative of the function f of x is equal x squared plus 2 is given by 2x, and we write it here f prime x is equal to x. So example 2, for f of x is equal x squared plus 2, find f prime minus 2, f prime 0, and f prime half, and f prime 1, then interpolate. So we need to go to the derivative, replacing any x by minus 2, then replace x by 0, replace x by half, replace x by 1. And we have seen that the derivative is equal to x. So from the previous example, at x is equal minus 2, we have f minus 2, the value of the function at minus 2, it is equal to 6, because 2 squared plus 2, it is equal 6. F prime minus 2, so we go to the derivative, replacing any x by minus 2, we'll get 2 multiplied by minus 2, which is minus 4. The point minus 2, 6 is called the point of tangency, whereas this one minus 4 is the slope of the tangent line at the point minus 2 and 6. So minus 4 represents the slope, whereas the point minus 2, 6 represents the point of tangency. The same way we do when x is equal 0, so f0 it is equal 0 plus 2, which is 2. F prime 0, so it will be 2 multiplied by 0, which is equal 0. So here the point of tangency it is 0, 2, whereas the slope it is equal 0. At x is equal half, we have f half it is equal half squared plus 2, which is 9 over 4. So the point of tangency it is half and 9 over 4, whereas f prime half it will be equal to multiplied by half, which is equal 1. So the slope at half it is equal 1. At the point x is equal 1, we have f1 it is equal 1 squared plus 2, which is 3, whereas f prime 1 it is equal 2 multiplied by 1, which is equal 2. So we have seen that for all these points we have a point of tangency and we have a slope. At the point 0, the slope is equal 0. So that means the tangent line is horizontal at this point. So if the slope is equal to 0, that means the function has a horizontal tangent line. So whenever the slope is equal to 0, the function has a horizontal tangent line. So now here we have a question: what is the slope of gx is equal x squared and the slope of hx is equal x squared plus 1 at x is equal 2? So here we have the function x squared and here we have x squared plus 1. We ask to find what is the slope of these two functions at the point x is equal 2. We have seen here we have the function x squared plus 2. Here we have function x squared and x squared plus 1. So are there any relation between the slope of these three functions? Let us see in the following graph. Three functions. The red one y is equal x squared and the blue one represents the function y is equal x squared plus 1. The green one represents y is equal x squared plus 2. And from the previous example we have seen that the derivative of f prime x of the function x squared plus 2 it is given by 2x. So this when f is equal x squared plus 2. Now we need to know what is the slope or what is the derivative of the function y is equal x squared and y is equal x squared plus 1 at the point 2. So at 2, so here we have 2. This function has the tangent line here, whereas this one has the tangent line here, and this function has a tangent line here. If you see all these three functions, they are the same function, just we shifted. So we start by the function y is equal x squared. The function y is equal x squared plus 1, it is the same function, just we shifted to the up by 1 point. The graph of x squared plus 2, it is the same, just we shifted by 2 points up. So here we have the graph of the this function. So all these three functions are the same except they are in the different place. So here we have this point, the head of this point is at 0, 0, here it is at 0, 2, this one at 0, 1, this one at 0, 2. And here we have different point of tangency of these three graphs. This red one has a point of tangency here, whereas the blue one has the tangent line here, and the green one has the tangent line here at the point x is equal to. But are they have the same the equation of the tangent line? Yes, because the difference is in the place, not in the shape of this function. So the derivative of the blue one, which is f of x, is equal x squared plus 1 f prime x will be equal the same, which is 2x, the same as the function x squared plus 2, because they are the same function, but the difference is the place of the point of this function. Also for the graph y is equal x squared, so here we have f of x is equal x squared, the derivative will be equal also 2x. So since they are the same function, just we shift it to the right or shift it to the up, we have the same slope. So the slope of the green one, we have seen that the slope here it is equal, so f prime 2, we evaluate this one, f prime 2 it is equal to multiply 2, 4. The slope of this one, so f prime 2, this will give us 2 multiplied by 2, 4. The slope of this one, so f prime 2 will be equal to multiplied by 2, which is equal 4. So all these three have the same slope at x is equal 2. But what about the point of tangency? Are they have the same point of tangency? No. Everyone have different points of tangency. So for this one, y is equal x squared, the point of tangency here we have it is 2, and we have the function y is equal x squared, so 2 squared will be 4. For the blue one, we have the point here 2, and the point of tangency it will be x squared plus 1, so it will be 2 squared plus 1, which is equal 5. For the green one, we have this point here, it is 2, and so 2 squared plus 2, this will give us it is 6. So these three functions have the same slope. Here we have it is equal 2, it is equal 4, this one is equal 4, this one is equals 4. So they have the same slope at the point 2, but different point of tangency. Why they have the same slope? Because they are the same function, just we shift it to up. So since they are a copy paste of this function, just we shift it up or down, that means they have the same slope at the same point, but the point of tangency will be different for every one of them. Example number 3, find the derivative of fx is equal x cubed. So here we need to use the definition, which is f prime x is equal limit of fx plus h minus f of x over h when h approach to 0 to find the derivative of this function.